If you seal a room in total darkness, why can an excited atom still choose to flash, even when no outside light is stimulating it? In the energy filament theory, nothing is choosing anything. An excited state is an energy inventory sitting inside the energy sea. And tension background noise TBN is the constant, tiny knocking that occasionally nudges that inventory across a closure threshold, releasing one coherent wave packet. Textbooks often say vacuum fluctuations trigger spontaneous emissions. And the sentence sounds deep only because we were trained to picture vacuums as literal nothing. In this picture, vacuum is the sea itself in its resting state. And the resting state is never perfectly flat. It has unavoidable micro wrinkles and faint jitters everywhere. Most of the time those ripples are too small to matter, like wind brushing a lake. But when an atom is perched near a critical release condition, that same wound can become a fingertip on a door latch. The mechanism becomes practical if you picture a warehouse with a locked loading dock. Step 1 is storage. The atom holds extra energy as a strained internal tension pattern, like inventory stacked in a back room. Step 2 is packaging. The inventory must clump into a self-consistent outgoing unit, crossing a clumping threshold so the packet has a clean envelope and an internal rhythm signature that can survive relay propagation through the sea. Step 3 is release. The loading dock needs to line up with the right windows and channels, and the system must cross the release threshold that completes one discrete settlement event. Here's the key: TBN supplies the knock. Most knocks arrive when the latch is not aligned, so nothing happens. Then one knock arrives when the phase happens to be just right. The alignment is close enough, and the door flips from not yet to done. What we call spontaneous is simply inventory is ready, and the sea finally tapped at the right instant. And notice what this automatically explains: the atom does not leak light as a continuous mist. When the threshold is crossed, it ships a box. One coherent wave packet goes out, with a definite color because color is a rhythm signature, not a paint job. Now look at stimulated emissions with the same warehouse image. An incoming wave packet is not a magic spark, it is a metronome. It pulls the atom's internal phase into lock, effectively lowering the release threshold and making the door click easier and more orderly. So the next outgoing packet matches the incoming rhythm and direction, stacking that phase locking inside a medium that keeps refilling inventory. And you get laser behavior. Coherence is not a personality trait of photons. It's what repeated locking does to thresholds. If you like the mainstream Einstein A and B coefficients, you can translate them cleanly here. A reads as background knocks plus threshold crossings, while B reads as external phase locking plus lowered threshold. Same accounting, but now you can actually see the machinery, and the lab-level details stop looking random. Short lifetimes and violent environments shake the latch faster, so spectral lines broaden. Boundaries and wave-guiding channels act like shaped loading docks, so emission becomes directional and polarized. Each single release is coherent in itself, but many releases filtered through a messy environment lose shared phase and turn into ordinary low-coherence thermal light. The punchline is simple: spontaneous emission is not causeless, it's TBN knocking. And radiation is not a continuous spray, it's threshold packaged shipments from the sea. Next up, the same one packet, one threshold logic explains why the photoelectric effect cares about colors like life or death, while intensity mostly just changes how many attempts you get per second. Tap follow, share it on New Physics, Clear Universe.